Welcome back to Next Now, your inside track on the infrastructure shaping the AI era. I'm your host, Nexus, and if you're enjoying these insights, make sure to subscribe. And you can also catch us on Spotify for your commute or workout. Today, we're diving deep into a fundamental shift happening in cloud architecture. Why Neoclouds are making data center interconnect the backbone of AI-ready infrastructure, and what this means for every organization building their AI future. The world of cloud computing is experiencing a seismic shift. We're witnessing the rise of a new generation of cloud providers, Neoclouds, that are fundamentally rethinking how cloud environments should be built. And at the heart of this transformation is something that used to be an afterthought: the interconnect edge, or how data centers connect to each other. For today's Chief Information Officers, Chief Tech Officers, and Chief Data Officers, this isn't just a technical evolution. It's a critical strategic differentiator that directly impacts competitive advantage, operational efficiency, and risk management in our AI-driven world. Let me start by explaining what Neoclouds actually are and why they matter. These are next-generation cloud platforms purpose-built specifically for AI workloads. Unlike traditional hyperscalers like AWS, Azure, or Google Cloud that try to be everything to everyone, Neoclouds focus laser sharp on what modern AI demands most: ultra-low latency, high-throughput GPU compute, and complete data sovereignty. We're talking about providers like CoreWeave, Lambda Labs, and in our region, Sharon AI and Gaia X aligned providers. These companies are designed to rapidly scale from a few GPUs to thousands, deliver the speed and performance needed for real-time AI inference and massive model training, meet strict compliance requirements for sensitive data, and integrate seamlessly with edge environments across cities, industries, and applications. This shift is particularly crucial for the Asia-Pacific region. Across APAC, demand for powerful AI infrastructure is exploding. Governments are investing heavily in AI capabilities, businesses are scaling intelligent services, and there's increasing pressure to keep sensitive data local and secure. Countries want more control over where their data resides, how it's processed, and what energy powers it. Neoclouds meet this challenge head-on by decentralizing AI infrastructure, delivering the performance needed for complex AI tasks, and adhering to local data and compliance laws. They bring the compute power of AI closer to where it's actually used, whether that's in hospitals, factories, financial institutions, or smart cities. But here's what makes this transformation so significant. In traditional cloud models, network interconnects were treated as infrastructure plumbing. In the era of Neoclouds, they've become the command center of performance and a critical strategic asset. Whether you're training models, delivering AI-powered services in real time, or ensuring compliance with local data laws, your entire cloud strategy now hinges on the quality of your interconnect fabric. Let me break down why Interconnect now leads cloud design into three critical areas: latency, throughput, and sovereignty. First, latency has become your new performance edge. AI applications, especially real-time ones, are extremely sensitive to delays. Even a single millisecond can make the difference between success and failure. Neoclouds are fundamentally reshaping data center interconnect with what they call metro spine architectures. Multiple high-density campuses linked across a city using fiber loops that deliver sub-millisecond speeds. These links aren't just failover options. They're active, high-speed highways that allow distributed GPU clusters to operate in perfect sync. The business impact is remarkable. Reducing AI inference latency by just 2 milliseconds can boost user engagement in real-time AI applications by 25 to 30%, directly increasing revenue per customer. In high-frequency trading environments, sub-millisecond advantages can translate to millions in annual profit. Second, we're dealing with unprecedented throughput demands. Training large AI models creates an explosion of data movement between compute and storage nodes, often reaching many terabits per second. Legacy cloud interconnects simply weren't built for this level of bandwidth. To meet these demands, Neocloud infrastructure relies on guaranteed non-blocking bandwidth with minimal jitter to maintain predictable performance even during data floods. They use optical mesh or dark fiber to provide high capacity, dedicated pathways, and implement programmable control through software-defined networking and dense wavelength division, multiplexing to dynamically allocate network resources. The business impact is substantial. Optimized throughput can cut large language model training cycles from 8 weeks to 4 weeks, accelerating new AI product launches by 50%. This means organizations capture first mover advantage and stay ahead of competitors. Third, sovereignty has moved from a niche concern to a top-tier boardroom issue across critical sectors. Data residency, transparent routing, and guaranteed jurisdiction are now mandatory requirements. This fundamentally changes how data centers and interconnects are designed. Workloads must stay within legal borders even during system failures. Traffic between sites must be auditable and predictable, giving organizations clear visibility. Data storage and replication need real-time compliance monitoring to prevent accidental cross-border movement. To deliver this level of control, Neoclouds use sovereign mesh architectures, interconnected campuses operating as a unified policy-driven regional cloud. This ensures full visibility, compliance, and resilience. The business impact of robust sovereign interconnect is enormous. It prevents massive regulatory fines, up to 4% of annual revenue for GDPR breaches, and opens access to regulated markets worth billions. For financial services, compliant interconnect is often a prerequisite for licenses that unlock hundreds of millions in market access. What's driving this strategic shift? It's not just technical, it's economic, regulatory, and deeply strategic. Cloud architecture is being redesigned to control costs, manage compliance, and support mission-critical AI use cases. Traditional hyperscalers often impose significant data, egress, and inter-availability zone transfer costs. For AI platforms moving petabytes weekly, these costs become unsustainable. Neoclouds use metro-local, high-throughput interconnect to eliminate expensive long-haul data movement, minimize latency penalties, and improve cost predictability. Metro-local interconnect can reduce data transfer costs by 60 to 80% compared to hyperscaler egress fees, boosting gross margins on AI services by 15 to 25%. For an organization processing 100 terabytes monthly, this translates to $50,000 to $200,000 in annual savings. From a compliance perspective, governments worldwide are tightening rules on where data lives and how it's handled. From Australia's Critical Infrastructure Act to Europe's GDPR and DORA, Neoclouds serving regulated industries must support jurisdiction-specific routing rules, proximity controls, and zero-trust network overlays. The shift is also being driven by real-world, high-stakes AI applications. National health AI exchanges need low-latency, jurisdiction-bound AI for real-time diagnostics. AI-powered fintechs under APRA regulation in Australia demand local storage, in-country redundancy, and observable connections for audits. Defence and space AI applications require mission-critical AI models in sovereign zones with zero cross-border data movement. We're witnessing an evolution from the old central hub model to a sovereign mesh approach. In the past, cloud infrastructure was built like a wheel with a big central hub and spokes stretching out to other locations. Everything had to go through the center, creating delays and higher costs. Today's Neoclouds use a distributed approach, a network of smaller, powerful cloud clusters located in major cities, connected directly to each other. Think of it like a network of smart cities that communicate instantly instead of always calling headquarters first. Security at the interconnect edge has become your foundation of trust. When we talk about data center interconnects, we're referring to the high-speed fiber links that connect multiple data centers together, often across cities or international borders. These interconnects carry some of the most sensitive AI data in transit between sites, making them growing targets for cyber threats. Robust interconnect security requires end-to-end encryption using protocols like MACsec or IPsec, advanced threat detection, deploying AI-powered systems that monitor traffic for unusual patterns, DDD mitigation to protect critical links, physical security for fiber optic cables and network equipment, and zero trust principles across the entire interconnect fabric. Comprehensive interconnect security prevents costly data breaches and protects invaluable AI intellectual property worth potentially billions in competitive advantage. There's also a significant ESG component to optimized interconnect infrastructure. Beyond reducing the need for long-distance fiber, an optimized interconnect edge contributes to broader environmental, social, and governance goals through reduced energy consumption, efficient resource utilization, and supply chain resilience. ESG optimized interconnect can reduce energy consumption by 20 to 30%, improving sustainability metrics that are increasingly vital for attracting investors and environmentally conscious clients. Looking ahead, the landscape continues evolving rapidly. We're seeing more automation in dynamic workload placement, deeper edge computing integration, requiring seamless, low-latency connections to distributed devices, interoperability challenges as the Neocloud ecosystem expands, and the need for specialised talent investment in network architects and engineers. The bottom line is clear. Neoclouds aren't just building inside data centres. They're building across them. The new cloud isn't regional, it's focused on metro areas. It isn't centralised. It's built around data sovereignty, and it doesn't scale by just adding racks. It scales by intelligently optimizing the network mesh. For organizations building AI infrastructure, understanding and investing in superior interconnect edge capabilities is no longer optional. It's fundamental. It's the platform upon which you'll deliver AI-grade performance at sovereign scale, across every metro area, every workload, and every regulation. This is exactly what Sharon AI has already achieved. They've launched a sovereign, scalable GPU as a service platform with 100% uptime across Australia, powered by NextDC's high-performance infrastructure. It demonstrates what's possible when AI meets purpose-built infrastructure designed for the demands of the Neocloud era. NextDC is uniquely positioned as Australia's leading provider of this next-generation infrastructure. With Tier 3 and Tier 4 certified facilities across all major capital cities, NVIDIA DGX Ready certification, and the only fault-tolerant Tier 4 facilities in multiple locations, NextDC offers the foundation that Neoclouds need to deliver on their promise of sovereign, high-performance AI infrastructure. The interconnect edge represents more than a technical upgrade. It's a strategic imperative that will determine which organizations lead in the AI era and which get left behind. The business impact is measurable. Reduced costs, faster time to market, enhanced compliance, and sustainable competitive advantage. The question isn't whether this shift will happen, it's already happening. The question is whether your organization will be ready to capitalize on it. Thanks for tuning in to Next Now. If you're building or scaling AI infrastructure and want to understand what sovereign, high-performance interconnect actually looks like in practice, stay with us. More insights coming soon. Make sure to subscribe to our YouTube channel and catch us on Spotify.